Okay, in our next regression example with the calculator, we're going to look at a quadratic regression. We're going to build a quadratic function. So if you look at the note sheets, here's our problem. It says the data in table 8 represent the percentage D of population that is divorced for various ages X. So again, in the table, this is our X's, these are our Y's. That's what we're going to put in for L1 and L2. They want us to draw a scatter diagram of the data, treating age as the independent variable, that's your X. Comment on the type of relation that may exist between age and percentage of the population divorce. So they're asking us, is it linear with a positive or negative correlation? Is it quadratic? Da, da, da. So we're going to, on your notes, I provided the graph. We'll graph this real quick, which is we're just going to plot these points. So go ahead and give you a little bit of a head start here. Plotting those points. Oh no, what happened to I blew it out again, doggone it. There we go, that's weird. Okay, so plotting my points. And looking at my data here, I notice that my X's are all increasing, so are my Y's, but then at some point they begin to go back to decreasing, which leads me to believe we have some kind of upside down U-shaped curve for my quadratic parabola. All right, so if that's going to be opening down, that means in my quadratic equation, x squared is going to have a negative a value in front of it. So there's going to be a negative number multiplied to my x squared to cause that to open down. So start to plot my points. 22 and 0.9, 27 and 3.6, 32 and 7.4, 42 and 12.7, 50 and 15.7, 60 and 16.2, 70 and 13.1, 80 and 6.5. So we can definitely see from our graph that we do have some type of parabolic shape, and it's opening down. And that justifies a negative x squared. So we're going to we'll hopefully when we do our regression, that value is going to be negative. All right, so there's my graph. Now, going to the calculator. I'm just going to finish up my slides and I'll, again, bring the calculator to the screen. So again, we want to enter our data through stat, enter our data into L1 and L2 like we did before. So go ahead and hit pause, get your calculator loaded up with the numbers. Again, I'll bring in my calculator. I'm just trying to shorten the video here a bit. Now that your data is in, we're going stat calc. Now we're going to do a quadratic regression, number 5, not number 4. And now you get the following window that says quadratic regression. Again, L1, L2 for X and Y list. Again, we want to put in Y1 into the store of the regression. Again, that's the alpha trace to get to your Y1. And your screen should show you the following values. So here's my quadratic function, ax squared plus bx plus c. A is negative, that's a good sign, 0.0143, bunch of numbers. B is 1.58, that's going to be multiplied to the x, and the c is negative 28.188, that's your constant value. Here is your r squared. This is your correlation coefficient, but it's been squared. So what we would have to do is write that down. If you want to see what your correlation coefficient value is, you take the square root of that number. So I wrote it down. I took the square root and I had 0.992187, a very strong correlation. These points are going to be really close to our quadratic parabola. So here's my function. Again, I just rounded it to 4 decimal places just to kind of quicken this up. So there was our original graph we did by hand. And what I did is I went to the calculator and tried to mirror image the graph by hand and the graph by the calculator, and you can see my points are almost right on. Then I put in the graph, and you can see how all the points are right there. And part C, the largest x can be determined by the graph using the max command. So for part C of the question, it says use the model to approximate the age at which the percentage of the population divorced is greatest. So we'll go to our second trace, do a calculation, choose maximum, and we should come up with a value of 55.39. So right around 55.4. And again, I'll bring the calculator in to do this. I just want to show you the procedures to do this. For question D, use the model in part B to approximate the highest percentage of the population that is divorced. That would be the 15.744735, or we can say 15.7 because our data gave us one decimal place in the y's. Part E, use your graphing calculator to make the graph we did. All right, so again, just so I can avoid that blue screen, we'll end the show. Bring my calculator back in. I already have the data entered. So once the data is entered, remember we go back to the home screen. We hit stat, calculate. There was number 5, the quadratic regression. Again, to get your Y1, whoops, one too many, into the store regression, alpha trace, Y1. All right, now, however, what I'm going to do this time is, this is for my TI-83 users. To get to your Y1, you have to take a little bit of a different route. You have to hit vars, go over to Y vars. You'll notice that tab popped up when I did my shortcut. Then function, and then there's my Y1. So it's a couple extra button pushings to get there. We'll go down, highlight, calculate, hit enter. Here are the same numbers we had. There was that r squared. Again, you would have to write this down and take the square root of it to find the actual value. But if we again go to y equals, there's the equation, completely stored. And again, you want the most accurate equation, store it. You don't want to type in all these numbers. It's ridiculous. If I want to graph this, again, we have to go change your window. We want it to go from 0 to 100. And let's see, looking back on my notes, we counted by 10. You look at your graph. Our Y-min, let's see, I guess I chose -4 so I can make it look just like the graph, and we maxed out at 20. And we counted by 4s. So the Y scale, the lines or tick marks will be 4. So I hit graph. There are my points. And there's my graph. And again, to find the relative max up here, the high point of my parabola, second trace, ask for the maximum number 4. Somewhere to the left, that looks good. You can hit enter. You can scroll. Once you go past the bump, that's good. Hit enter, enter on the guess. And again, there's the 55.399429 that we had earlier with the 15.744%. All right. And that will take care of our calculator regressions. Make sure you know how to turn your diagnostics on, because on the test I do ask for that correlation coefficient, the R value.